The key to a good solder joint is preparation and following sound soldering practices. The first thing is the preparation process, and the preparation process involves several steps. The first of those steps is the cutting of the pipe. You can cut the pipe different ways, but the only real acceptable way is by using a tubing cutter. After you mark the pipe to the appropriate length, what you do then is just open up the cutter, set it on the mark, and make your cut by rotating the cutter around the pipe and tightening it as you go. And once that cut is made, then you're ready for the next step, which is preparing the pipe.
Next, Frank uses a deburring tool to remove burrs and sharp edges from the copper.
The next step is the cleaning process. The cleaning process can be done a couple different ways. You can use a tool like this one here, which is a external cleaning brush, which is really just a wire brush that's made specifically to clean the outside of the copper. Or you could use sand cloth or grit cloth. The end results are very similar. The next part of the process would be preparing the actual fitting. Once again, there are two different ways that you can clean it. You can use the sand cloth, or you can use an internal cleaning brush. We clean, in this case here we're talking about a T, so we can clean all three sockets of the fitting using the brush. Once the copper pipe is prepared and is cleaned, and once the socket of the fittings are prepared and cleaned, now it's very important to keep them that way, not to contaminate them by getting dirt, dust, even the oil from your fingers on either the pipe or the fittings. So it's important how you handle it at this point now. Make sure you put it on a clean surface and you don't put it any place where it could be possibly contaminated. The same holds true for your flux. It's important that you keep the flux covered when you're not using it, keep dirt and rust from getting in there, and try and keep the brush as clean as possible, or just buy a new brush as needed. Now that we've already prepared the pipe and the fitting for soldering, now it's time to start applying the flux. This particular piece of copper here has already been pre-cleaned, but it has not been fluxed. So I am now applying flux to the outside of the copper. And next I'll be applying flux to the inside or the socket of the fitting. You need to have a complete coating of the full exterior of the pipe and the full interior of the actual fitting, the socket of the fitting. There's different ways to solder, and there's different techniques. Some people who are very experienced, after they apply the flux, will put an additional coating of flux right at the socket of the fitting, thinking that it'll guarantee that the solder will be drawn properly into the socket. When we used to use 50-50 solder, it melted at a lower temperature. And for that propane gas was more than sufficient. With lead-free solder, it melts at a higher temperature. So just for the sake of expediency, using a more high-temperature gas like MAP gas works much better. Typically, when you're soldering a joint, you're not working in a controlled environment as we are today. Typically, you're working in a place where you're working in a ceiling, you could be working in a wall, you're working in a floor space where there's a lot of different flammable material. Since we're working with an open flame, it's very important to be able to create a barrier between that flame and any kind of combustible surfaces. There's different ways to do it. You can do it with something as simple as a piece of sheet metal, or there's products like a soldering heat shield, which is a fire-resistant fiberglass blanket that also acts as a barrier between the flame and any kind of combustible surfaces. If things do go bad, and if small fire does happen, it's always important that you have a fire extinguisher readily available. Well, at this point here, the pipe and the fitting is prepared for soldering. So what we need to do is, what we have here is we have a self-igniting torch, and we're using MAP gas. We'll turn the torch on. We have lead-free solder here. What we'll do is we will apply heat to the actual fitting. As we're applying the heat, we're watching the flux and watching and see how it bubbles. Once the solder starts flowing, we can remove the heat and go on to the next socket of the fitting. And we're done with that joint. We have a pipe that is joined to the fitting with solder. The socket right now is full of solder. And if we allow it to cool normally, we know that we'll have full coverage. If we touch it, if we disturb it, we're always taking a chance of no longer having that full coverage. The best thing to do after you solder a joint is to let it cool normally. By not touching it, you're not disturbing the joint, and you won't be damaging the integrity of the joint. Oftentimes when people are working quickly or doing production work, after they solder the joint, what they'll do is they will spray the fitting with a spray bottle of water, or take a wet rag and wipe the fitting.